Welcome to The Explainer. Today, we are going to tackle the three fundamental building blocks of Kubernetes: pods, deployments, and services. Seriously, if you've ever wondered how the biggest apps in the world stay online and scale to millions of users, well, the answer starts right here. Okay, let's dive right in. So you've done the work, right? Your application is all neatly packaged up inside a container. Maybe it's a Docker container. And that's a huge first step for sure. But the real question is, what now? How do you take that one little container and actually run it reliably in production? Because just running it, that's not enough. You've got to handle failures. You need to scale up when traffic spikes, and you have to connect it to everything else. And this is the core difference we need to get. Think of a container platform like Docker as a tool that manages an individual soldier. It's great at that one job. But Kubernetes is the general. It's orchestrating an entire army of those soldiers. It's the brain that gives you these incredible superpowers like self-healing and automatic scaling. I mean, these are the exact things you absolutely need to survive in a real production environment. So how does Kubernetes even start to solve this massive management problem? Well, it doesn't just run your container directly. Nope. Instead, it wraps it in this special new layer, its most fundamental, most basic building block, the pod. The easiest way to think of a pod is like a tiny, dedicated little computer built just for your container. It's the smallest thing you can actually deploy inside Kubernetes. And here's the key part. The pod gets its own private IP address on the network. It creates this protected little bubble for the container, or sometimes multiple containers that live inside of it. So what does a pod actually do? Well, it basically takes what would be a super complex command line instruction and turns it into a simple configuration file. So instead of telling Kubernetes how to run your container step by step, you just describe what you want in that file, and Kubernetes just takes care of the rest. This simple idea is what makes your container an official manageable citizen of the whole cluster. Okay, but this brings us to a really critical problem. Pods, just like the containers inside them, they're disposable. They can crash, the machine they're running on can fail, and poof, they're gone. A single pod is a single point of failure. If it goes down, your app goes down with it. And that is not the kind of reliability we were hoping for, right? So to solve this, we need a manager. We need something at a higher level to watch over our fragile little pods. And that is exactly what a deployment does. You see, in the real world, you almost never create pods by themselves. You create deployments to manage them for you. A deployment is basically a supervisor for your pods. You give it a simple blueprint. You just say, hey, I need 3 identical copies of this pod running no matter what. And from that moment on, the deployment's only job is to relentlessly, tirelessly make sure that blueprint is the reality. And this is where the magic really starts to happen. A deployment acts like this vigilant robot manager. The second it sees one of its pods fail, its controller instantly springs into action, creating a new, healthy replacement. This is that famous auto-healing that makes Kubernetes so resilient. It's literally a system designed to fix itself. So let's look at the chain of command here, because it's pretty clever. You, the user, you only ever talk to the deployment. The deployment is the strategist, but to execute its strategy, it creates a little worker object called a replica set. Think of the replica set as the grunt on the ground, whose only job is to make sure the right number of pods exist. It's the one actually doing the dirty work of creating and deleting pods to match the deployment's orders. But wait a minute. This whole automated healing thing, it creates another problem. When a pod dies and that replica set replaces it, the new pod gets a brand new, totally different IP address. So if other parts of your system were trying to talk to the old IP, that connection is now broken. How can anything find your application if its address is constantly changing? So what we need is a stable front door. We need a single, unchanging address for our group of constantly shifting pods. And that is the exact job of our third core component, the Kubernetes service. A service is like a permanent network identity for your application. It gives your whole group of pods one single stable IP address and a consistent DNS name that never changes, even when the pods behind it are being created and destroyed all the time. It effectively hides all that chaos from the rest of your system. And this is why it matters so much. The service also acts as an internal load balancer. So when a request comes in to the service's stable IP address, it automatically forwards that traffic to one of the healthy pods that it's managing. This means other applications don't need to know or care about individual pod IPs. They just talk to the service, and that ensures your application is always discoverable and always accessible. All right, let's zoom out and just look at the complete picture we've built here. We've gone from a single, fragile little container all the way to a resilient, self-healing application. You can see how each layer in the stack solves a very specific, critical problem. The container packages the code. The pod gives that code a home to run in. The deployment acts as a tireless manager, making sure those pods are always healthy and scaled just right. And finally, the service puts a stable front door on the whole thing, making the entire application accessible and truly reliable. And this leads us to our final thought. Now that we have this awesome, stable, self-healing system running, what happens when we need to update our app to a new version? Deployments actually have built-in strategies to do this without any downtime, but there are even more advanced methods out there, like canary or blue-green deployments. So how do those work, and which one is right for you? We'll explore that next time.